Hi guys, and welcome back to Learn Extra Live. It is a Monday. That means it is a maths, and I'm losing my words today. So Doctor has asked me, the average of 1, 3 and 5 is 3. Does this mean an average is the mean? And yes, it does. Mean is the same word that is used for average. So you are completely correct, Doctor, and well done. And thank you for posting that on our page. But before we go any further, I just want to remind you guys that the best post is going to get this awesome Casio calculator today. And we will be posting the winners from last week on the page in the next 10 or 15 minutes or so. So if you want to be watching those on the page, it's facebook.com/learn extra. And before I take too much of ET's time, I just want to give a big shout out to Liberty. Thanks, guys, for making this show possible. You guys rock, and we think that you're absolutely awesome. So without further ado, ET, take it away.
Thanks, Indiana. Let's continue. Yes, I have talked about the measures of central tendency and the quartiles. I would like to talk about the quartiles in particular. What I have worked out is how you can actually determine where your quartiles are given a certain size of data. All right. So what I have here is that quartile 1 could easily be seen as n plus 3 divided by 4. Notice that I'm using 4 in these three expressions: quartile 1, quartile 2, and quartile 3. All right? And in fact, if you look at this, there is a pattern. There is a pattern with this expression, easy to remember. So if you want to know the position of your quartile in the data, you're going to take for quartile 1, you're just going to take, let's say you had 5. You're going to say 5 plus 3 divided by 4. Then you get the position. That is 8 over 4, which is the second position, basically. And that's how you use that. Once you know the position, you can then go and say, either you pick the actual value if it's a whole number, or if it's a fraction. You have to do what you call interpolation. That is I've actually worked out some expressions for interpolating here, but it's a subject that you'll have to learn a bit later if you do not know about it already. All right. So if we go to Q2, you will notice you may have come across an expression that says n plus 1 divided by 2. Indeed, that matches up with this, because if you take out a common factor of 2 here, if I can just pick on that one, if you take out a common factor of 2, you're going to have n plus 1. That is divided by 4. 2 goes once, 2 goes twice. Then you end up with n plus 1 divided by 2. All right? And for the third quartile, that's 3n plus 1. So in other words, for the five data points that we used earlier on, we could say n is 5, which means we are going to say Q3 position is going to be at 3 times 5 plus 1 divided by 4. And that gives you the 3 times 15. 3 times 5 is 15. You add 1, you get 16 over 4. And that is equal to the fourth position in your data when you have put them in ascending order. You'll notice I keep emphasizing that. Whenever you're dealing with the medians, the quartiles, you have to line up your information in ascending order. All right. What else is there? Let's just see. Yes. Now that you know the position, and you've been given data, so all you have to do is then go and say, okay, fine. If I want my first quartile and I know the position, if the position came out to be a non-whole, in fact, this I use only for the case when, if this is now the value of your quartile in the data when calculated position is not a whole number. If it's a whole number, you just go and pick it from the data, straightforward. The challenge is when it's, it says 2.5, especially if you have got an even number of data points. So you're going to end up with 4 this side or 4 that side, or 3 this on one side and 3 on one side. Now, right in the middle there, we are interested in getting this thing right in the middle. So you are going to get position, in that case I said 8, so in position 4.5. Now, obviously, you can't say that's a position. So, but if you calculated using this and it came to that, you then go and use these expressions that I've outlined here. For the first quartile, that's what that's the value that you'll get when you substitute. Now, P and P plus 1 are 2 positions to the left and to the right of the calculated, non-whole number. If you had 2.5 as the calculated position, you then take 2 and 3. So let me just take one simple case. All right. So all I'm saying is, if you found your position for Q1 to be 2.5 when you calculated, now you then say, then my position must be, I'm going to use this as P, and I'm going to use the other side, 3, as my position P plus 1. Okay. So what you'll notice there is my subscript or my index is actually trying to show you that. So you'll say XP plus, 3 times XP plus XP plus 1. Notice that those are, subscripts. All right. And that you divide by 4, that will be the exact value that you are looking for. So you now have expressions that you can use to find your quartiles. So notice that there is also a pattern in that you've got 3xp here, you've got 2xp over there, and then xp. So that is 1, 1, 2, 3. Then the p plus 1, the xp plus 1 is in ascending order. So it grows with the quartiles. The other one actually goes down with the quartiles. And I should have mentioned as well, with the actual positions, you'll notice that pattern as well. You'll have a 1, a 2, and a 3. So that's a pattern there. As you go from smallest quartile to the biggest, that additional value there, that constant value there, actually decreases. All right. And the other side is the opposite to that. Okay. So yeah, that's what you can use. But if you have learned another method, you're welcome to use that. But I'm leaving it for a little while here so that you can just get time to write down all those things. All right, so you must have seen the order there. Let's move on and take an example. I think we can take an example at this point. Oops. All right, was that one? All right. All right, before we get to that, I think let's attack one more measure of central tendency, the mode. Yeah, I nearly forgot that. A measure of central tendency called the mode, it's also that value which you want to use as a reference. It's a reference value in the data which, due to its highest frequency of occurrence or appearance in the data, it leads to it being a predictable choice in terms of outcomes. So if you're waiting to see what will pop out, I don't want to talk about gambling, but the gamblers will actually say, well, this machine is actually giving you more winnings than the other machine. So everyone is flocking to that machine. So that's the kind of thing you're talking about here. So that's a mode. All right. So it makes the outcomes predictable. All right. And I have picked a few data points there. These measurements, you've got 21, 46, 34, 33, 33. Now, you will notice that 33 is appearing most of the time in this information. All right? 33 here, 33, there it is again. If I were to show you, let's say we list these things, that would be 21 appears once, 46 appears twice, and 34 also twice, and what else? 33 appeared 1, 2, 3 times. All right, and we still have 47 there just to finish it up. So we have got 46 done. 47 appears once. So there is what we mean by a mode. All right, that's just one simple example to illustrate that point. That was another measure of central tendency. Remember, we talked about the mean of data, the median of data, and the quartiles. And we are now talking about the mode. And yeah, I think we can now think of how well you have collected data. Remember we said you're collecting data, you're going to evaluate it and analyze it, and then, present that information for use. Now, the question is, how can we represent this data graphically, for instance? Remember, your analysis is either going to be algebraic or graphical. So for now, we're going to look at a few ways in which we can bring this information out in the form of a picture. Typically, the bar graph or the bar chart, the histogram, those kind of graphs. All right, that's what we're moving into. All right, the first one that I have here in graphical representation of data is the pie chart. The pie chart, this is where you take information that you have and you basically represent it in the form of sectors. And those sectors actually represent, have a relation to the percentage which is represented by your measurement. So in this case, if we take the total quickly of this, I'll draw. I want you to come with me in terms of drawing this thing. 21 and 29. Let's see, there's 25, 30. Okay, fine. That is 50 plus 30 plus 25. So that's already 105 plus 32. So the total here is 137. All right, the total of this data is 137. If I want to represent those, I've given these things names. It could be industries, or it could be departments, all right? The A, B, C, D, E that I've represented there. So they all have a portion of the pie, all right? So out of 137, you're going to work out that, okay, let's take A. You're going to work out that out of 137, you've got 21 for A. All right? And that comes out. Now, you have to, this is now a fraction of the pie, but you have to work it out in degrees. Okay? Now, which means this fraction must be a fraction of your 360 degrees. Now, let's not forget, if you go all the way around, this is going to describe a revolution, okay? A revolution, okay? A revolution is that angle that takes you all the way around, to complete a full circle. Now, if you want to know how you're going to represent this over there, this fraction, you'll have to multiply that by 360 degrees. All right. And I would like, actually, I haven't worked this out. I would like you at home to just use this as, a way of practicing this, okay? Because in the end, the degrees that we get, you're going to get degrees here. The degrees that we get must add up to 360 degrees. All right? For B, it's going to be 25 divided by 137, that you multiply by 360, because that's the full circle there, and you're going to get a value there in degrees. All right. If I can just work it out, say here, just to keep the same face here. So for C, you're going to have, what is the value? 29. 29 divided by 137. You multiply that by 360 again. 360 degrees, and you get your degrees. And D, you're going to say 30 divided by 137. That you multiply by 360 degrees. Then you get your degrees again there. So in the end, you've got E equals to 32 divided by 137 times 360, and you work out the degrees over there. Now, this was an artificial question from me. So now I'm going to just represent these things in this circle according to what is big here. But yeah, you'll have worked out the 5 areas, the 5 sectors based on degrees, and you're going to therefore divide this circle into the degrees that you got. So the biggest pie will be 32. There are 5 parts. Let's say 32 there, and 30 close to that. What do I say? This is now 32E, and this is D, let's say. And then 29 is for C, let's say. Wow. And for A and B, there is quite a big part, but obviously let me just make this proportion look right so that you don't get scared, obviously. So if I divide this, slightly bigger then. Okay, maybe one more there and something like that. I've got 5 parts there. I'll call this A, B, C, D, E. Now, you will be putting your protractor at the center there, and you'll measure those angles. So as you represent the angles that you have calculated here, this is what it will add up to. That's what you call a pie chart. And of course, you must give it a title. But yeah, that was just to illustrate the point. I want to cover a few more.
Should we take a break, E.T.?
All right. Yeah, I think I need a break, eh?
Yes, let's have a break.
Dry
I know.
in the mouth.
Okay, guys, so instead of talking about pies, maybe we want to go and eat a pie. I don't know, because now after all this pie talk, I'm kind of hungry. So we're going to take a quick break, and we'll see you now.